You check your phone before you even get out of bed. A little red icon. Extreme heat warning. Again. This is the fourth one this month, and some part of you has stopped being surprised. Here's the answer. The reason isn't actually the heat. It's the sky. 6 miles above your head, wrapped all the way around the planet, there's a giant river of air, and it's slowing down. Picture Earth's river of air circling the whole planet 6 miles above your head, separating cold Arctic air from the warmer air underneath. Scientists call it the jet stream. For most of human history, it moved the way a river should. Fast, steady. It swept weather systems across entire continents in a matter of days. Hot spells came, got pushed along by that current, and left. Nothing overstayed its welcome. Now picture that river losing pressure, slowing down, starting to wander instead of flow. That's exactly what's happening. And here's why. Climate scientist Jennifer Francis at the Woodwell Climate Research Center has spent well over a decade tracking this shift. The Arctic is warming nearly 4 times faster than the rest of the planet. 4 times faster. Let's sit with that for a second. When the Arctic heats up that fast, the temperature gap between it and the equator starts shrinking. That gap is the engine. It's the entire reason the jet stream moves with any force at all. Shrink the gap, and you shrink the force behind the current. The river stops running in a tight, disciplined line. It starts to wobble. It bends into huge, slow, lazy loops, the way a garden hose droops once the water pressure behind it drops. And when one of those loops parks itself directly over a city, it doesn't move on. Not for days. Sometimes not for weeks. Remember Earth's river of air? This is what it looks like when it stalls. Meteorologists have a name for this now. A heat dome. Picture a lid clamped down over an entire region. Now picture that same lid on a pot of boiling water, trapping every ounce of steam underneath it with nowhere to go. High pressure presses down. Air sinks, compresses, warms as it falls, the way a bike pump heats up in your hand when you push it fast. Nothing escapes. Nothing cools. You feel it on the ground as a Tuesday that simply refuses to end. Some heat domes have sat over the exact same region for 2, 3, even 4 weeks straight, long enough for reservoirs to drop, for power grids to strain, for entire crop seasons to be quietly written off before harvest. Here's where it gets counterintuitive. You'd assume the planet just got a few degrees hotter, evenly, like a blanket thrown over everything. But a few degrees is deceptive. It doesn't spread out gently. It concentrates violently, right at the extremes. A shift in the average barely nudges a normal afternoon, but it multiplies the odds of your absolute worst day dramatically and makes that worst day show up far more often. There's a group that proves this case by case. It's called World Weather Attribution, co-founded by climatologist Friederike Otto. After nearly every major heat wave now, they run something close to a forensic investigation. They rebuild the climate as it statistically would have looked without human-caused warming. Then they hold that reconstruction up next to what actually happened. The findings keep landing in the same place. Events that would have been almost impossible a century ago are now merely rare, and rare is a very different word than impossible. Here's the detail that should genuinely unsettle you. Picture the Pacific Northwest in the summer of 2021, a region famous for rain. Famous for mild summers. Now picture the thermometer there climbing past 116 degrees Fahrenheit in towns that had never once needed air conditioning. Otto's team concluded that event was virtually impossible without climate change already loaded into the system. Not unlikely. Virtually impossible. And it happened anyway, which tells you something important. The models weren't wrong. Reality had simply stepped into territory the old statistics never accounted for. None of this is entirely new, though. In 1936, during the Dust Bowl, a heat wave scorched the central United States for weeks, killing thousands before air conditioning was common. In 2003, a heat wave settled over Europe for most of the summer, contributing to roughly 70,000 deaths, many of them elderly people alone in apartments with no way to cool down. What's changed isn't that heat waves exist. It's the frequency, the intensity, how long each one lingers. The 2003 heat wave was once considered a once-in-a-few-centuries event. Today, similar or worse events show up somewhere on Earth almost every year. That's a baseline quietly shifting under everyone's feet, one summer at a time. So why does something this dangerous keep sneaking up on people, generation after generation? Like, it's a total surprise every time. Because your brain wasn't built to notice slow escalation. It was built to notice sudden danger, a predator moving in tall grass, smoke curling under a door, a loud crack in the dark. Heat doesn't announce itself that way. It creeps. 1/10 of a degree at a time, spread across decades, which is exactly the timescale human attention is worst at tracking. Researcher Camilo Mora at the University of Hawaii led a global study mapping deadly heat across the last several decades. One line from that research tends to stop people cold. By the year 2100, if emissions stay on their current path, nearly 3 out of every 4 people on Earth could face at least 20 days a year where heat alone poses a genuine risk to life. Not uncomfortable, not inconvenient, lethal. And cities quietly make it all worse in a way that has nothing to do with the atmosphere at all. Picture a city as a giant brick oven, one that's been left on since sunrise. Concrete and asphalt soak up sunlight all day, storing it like a battery, then release that heat slowly through the night, long after the sun goes down. Scientists call it the urban heat island effect. A city can run 5 degrees hotter than the farmland 20 miles outside it, sometimes 10, simply because of what it's built from, which means the very places where most of humanity lives are quietly manufacturing an extra layer of their own heat, stacked on top of a warming planet, stacked on top of a river of air that no longer clears the heat out on schedule. Some neighborhoods, the ones with the most concrete and the fewest trees, run even hotter than the rest of their own city, which means the people with the least shade and the least access to air conditioning often face the worst of it. Layer these together, and you stop seeing 3 separate problems. You start seeing one feedback loop. The Arctic warms, the jet stream weakens and loosens. Heat domes settle in and refuse to leave on time. Cities trap that heat all day and radiate it straight back after dark, so nights stop offering any real relief, and human bodies, which depend on cool nights to recover from brutal days, start losing that recovery window entirely. Your kidneys work harder. Your heart works harder. Sleep gets shallower night after night, and a tired body handles heat far worse than a rested one. It's a slow squeeze, not a single blow, which is exactly why it's so easy to underestimate, until it's already too late for the most vulnerable people around you. Emergency rooms see the pattern every single year now. A slow climb in heat-related visits that peaks not on the first hot day, but somewhere around day 4 or 5. Once the accumulated strain finally catches up. Here's the twist that catches almost everyone off guard. Earth's river of air isn't just stalling in one place either. You'd expect a warming planet to bring nothing but more heat. Instead, some of these same atmospheric changes are also linked to sudden cold snaps and severe winter storms in entirely different regions. That same wobbling river doesn't only trap hot air in one place, it can just as easily scoop a mass of Arctic air far south, dumping snow onto regions that almost never see it. The planet isn't simply getting warmer in a smooth, even way, it's getting less stable. The old rulebook for what weather is supposed to do in a given season is quietly being rewritten in real time, and nobody sent out a memo. Think about how many small, ordinary decisions have already reshaped themselves around this. Schools delay outdoor recess, or cancel it on days that would have been unremarkable 20 years ago. Marathon organizers move race start times to before sunrise. Utility companies now brace every year for rolling blackouts, not from some rare mechanical failure, but because millions of air conditioners switch on at the exact same moment, all pulling from the same strained grid. Farmers watch crops fail from heat alone, cooking the plant tissue before it can even use the water still sitting in the soil. Airlines have started delaying flights on the hottest afternoons because extreme heat literally thins the air enough to affect how much lift a plane's wings can generate. Even asphalt has started buckling on some highways, rippling and cracking under the kind of sustained heat it was never engineered to handle. None of these are dramatic disasters on their own. They're just small, quiet adjustments. But stack enough of them together year after year, and you're looking at a civilization slowly renegotiating its relationship with an entire season. Which brings us back to that red icon glowing on your phone. That warning was never really about one hot week. It's a small, blinking signal coming from an enormous global system that used to run on a steady rhythm and now runs on turbulence instead. Every extreme heat warning, every heat dome parked over a city for 10 straight days, every out-of-nowhere winter cold snap. All of it traces back to the same wobble, 6 miles above your head, in a river of air most people never think about at all. That red warning on your phone isn't just telling you today's forecast. It's telling you the rules of summer are changing. And for the first time in human history, we're watching those rules change while we're living through them.